Hello again, friends. I hope you're doing well. Welcome to the final session of this tutorial series. In this session, we're going to finalize our project, write its code, upload it to the microcontroller, and see the final result. All right, let's start with the Arduino software. As for its installation, well, that's a given. Anyone who works with Windows, you just download the .exe file and install it. There's really nothing special to it. And if you don't know how to do this, I suggest you close this first course and take a short Windows tutorial course. It's very simple. You go to the Arduino website, click on Download for the Windows version, and the .exe file will be available for you. You install it without any particular difficulty, and after you open the software, there's a very important thing you need to do. If you remember, I mentioned this in previous sessions. The ESP8266 is not one of Arduino's default boards. It's a board that you need to add, and it was supported later on. To add it, you need to go to the File menu, select Preferences, and here in this window, there's a section called Additional Board Manager URLs. In this section, you need to enter the link related to the ESP, and this link will be provided to you as well. As you can see, this is the link for the ESP8266 that I've entered here. You should delete anything that's already here, or if you've previously added another board. For example, if you have added ESP32, you need to separate the links with a comma. But make sure to also add the ESP8266 here. After you've entered it here, just go to your Board Manager section. And you'll see that in the board, your manager, the ESP8266. It will only appear here once you add that link. Otherwise, nothing will be displayed for you. After it appears, it's very simple. You just click on Install here. Right now, I'm using version 3.3.2, which I had already installed before, so I'm not going to install it again now. Just so it doesn't take too long because of the internet speed, but you can easily use the latest version without any issues. After you've installed it here, go to the Tools menu in the Boards section, and like me, for example, I've already installed several boards here. For you, only the 8266 will be displayed. Just go to this section and select the board you want. If you have a Node MCU, or if, like me, you have a Wemos D1 Mini, and then das was Fuitadietain. If you've bought any other board, you can select it from this section. Right now, my board is a Wemos D1 Mini, so I've selected this option. So, what settings does it have? Preferably, you don't need to change any of its settings at all, and you just need to come here and select your serial port, which you'll do after you've connected the module to your system, and if it needed a driver, it gets installed and the serial port is recognized. Here, a COM port will be added for you. If you have several of these COM ports, the best way is to right-click on your start icon, go to Device Manager, and in this section, go to the Ports section. Right now, the board I'm using is the Wemos D1 Mini IC. The serial chip on it is CHC140, which is the same cheap IC model. And here it shows me that my USB serial CHC140 is now on COM 8, so that means the board is connected. I am. Right now, it's connected to COM 8, which is also selected here. After that, we have some other settings, but they're generally not necessary. You don't need to change anything here, and I'll just keep the speed on this for a few seconds. If yours is set to something else, it's better to change it to these settings. These settings are for things like programming speed, memory structure, and tasks related to device clock speed. The microcontroller's default is 80, which is very important, and for most tasks, it's sufficient. You don't need to switch to 160. 80 is completely enough. So try to go through your initial lessons with these settings, and then we'll start with ARM. We'll get familiar with these options, or you can look them up yourself and get to know them. They're not things you'll be dealing with every day. They're more specialized topics that we don't want to get into right now. After you've done this, now you should go and start coding. Well, before we start coding, we need to import our libraries. When we want to use the ESP8266 as basically like a mobile hotspot, for example, when you activate the hotspot on your phone, what happens? Your phone acts like a modem and others can connect to it, just like the modem ID that we commonly have at home. It works in such a way that it creates a Wi-Fi network and others can connect to it. Now this type of Wi-Fi is called an access point. meaning the modem ID we have at home becomes an access point, or our phone in hotspot mode access point. So the first thing you need to be familiar with is this. This means that we are going to set up the ESP8266 Wi-Fi module in access point mode, so it will appear to other devices just like a modem. The second thing you need to know is that we need to create a web server on the ESP8266, which this web server allows us to handle various requests sent to our ESP as an access point, and it responds to those requests, meaning it acts as a server, and for example, you as a user who connects with a phone can send different commands to this server as a client. Alright, so these were the basic points you needed to know. So what library do we need? The ESP8266 web server library. After this library, we imported the html.h file. This is so that we don't have to put the HTML code inside the main code, which would make our page cluttered. From this section, we go to the New Tab option and open a new tab. Name it html.h, and in this section, we put the HTML code. Now, this HTML code needs to be in character format, meaning the program shouldn't recognize these as commands. The entire code should be sent to the user exactly as it is, without the program knowing what it is. So, we need to store these as a character array. For this, you need to have at least a very basic understanding of Arduino, and I hope you do, because if we want to explain those things as well, it would turn into a complete microcontroller training course, which is a whole different topic and outside the scope of our discussion. Right now, we're here to review our work in a project-based manner. So we create an array of type char, and we also put const before it. This means that the array is constant and will be stored in the microcontroller's main memory, not in its RAM, so that the microcontroller doesn't run out of RAM, freeze, or encounter any issues. This const ensures that it is stored in the microcontroller's main memory. What is the name of our array? It's HTML page, and in order to put all these lines together as a single string, we need to put these two symbols at the beginning and end. These two mean that anything placed between them should be inside this character string. So it gets saved. These were some basic points that we needed to be familiar with. Now let's move on to our main code. The main code is also written very simply and straightforwardly, and there aren't any particularly complicated explanations. I want to solve the problem for you very quickly and in an easy to understand way. After we created this HTML file and put these items in it, let's come here and import this file into our program. After that, we use define to assign something in place of something else. Now here we've done this. We've set the string CWS in place of SSID and the string 1234567 in place of the password. That means anywhere in the program where we write SSID, it's as if we've written CWS. So here we're specifying the SSID and password for our microcontroller's Wi-Fi. In the next step, we assign the microcontroller's pins to the relays. We say let pin D0 be for our first relay, pin D5 for the second relay, and so on up to the fifth relay. That means anywhere in the program where we write it. For example, relay 3 underline P, it's as if we've written D6, so that's how the define function works. After that, we need to assign an IP to our ESP board. This IP is necessary so that when we connect to the board, we can enter this IP in our browser and view our page. There's an option here called local IP. We enter our IP, which must definitely be in this format. 192.168.1.10 means that the standard format for local IPs is like this. Even now, when you're probably connected to your ADSL modem, if you go to your phone settings or your computer settings, you'll see that the modem's own address is 192.168.1.1, and your system's address, for example, could be 192.168.1. say 50, or ending in 7, or ending in 102, like this. And it can be anything from 0 to 255. So preferably, use this same format for the subnet and gateway as well. Don't change it at all. These are specialized network settings that we don't want to get into. And your local IP is the IP you want to enter in your browser to access your device. Enter it, and again, preferably keep it in this current format so you don't run into any issues. After that, we use the ESP8266 web server to create a server. With port 80, the standard HTTP port is 80. What does that mean? For example, when you search for a website, say you type google.com, it connects to the server that Google is hosted on through port 80. So when you have a server running on port 80, you can easily access it just with the plain IP address. But for example, if your port here is say 443, you have to specify the port number in front of the IP, which makes things a bit more complicated. So we use the standard port 80. After that, here we created another array. We defined it as HTML buffer with a size of 1,500 characters, which we'll put into the code. We'll explain it. For now, just know that we have a 1,500 character string here. Now we get to our void setup and void loop. In Arduino, if you're familiar, void setup is something that runs once, and void loop is something that runs continuously. So in the void setup, which runs once, we need to do our initial configurations. Like what? For example, with the pin mode command, we set each of our relays to output mode one by one. That means the pins on the microcontroller to which the relays are connected are set to output mode, so that it can control these relays. We do the same thing for all 5 of our relays. After that, we go ahead and set up the Wi-Fi. With the Wi-Fi.softapconfig command, we assign it the IP address we've specified. These items, it's exactly these things that we've specified here. The local IP, gateway, and subnet, which we've set here, and in the next step we'll mention them. Start the Wi-Fi as a soft AP, meaning as an access point. With what? With this SSID and password. And the password was what? The thing we entered here. We could also put these directly right here. But, well, so that you can easily change this, we've first set them in the code using the now defined command. And another very important point you need to know in this section is that there are no particular restrictions on the SSID. But your password must be at least 8 characters long, and if you want your Wi-Fi to be without a password, you need to leave the password field empty like this, and in this way your ESP will create a Wi-Fi network without a password with the name you want. So up to this point we've turned on our Wi-Fi. Now all devices can connect to the ESP, but we still haven't set up a server on the ESP yet. This part is our most important section, which maybe most users' problems are in this section, and if you get this part completely right, there won't be any issues left that we need to address. Let's explain it and move on to our server. For example, when we go and search Google here, now don't worry about the things that come up afterward. When we search for Google, we see that there's nothing in front of it, it's untouched, but if another link is added to it, or there's no specific command to go to a particular page, it just wants to go to google.com itself. So when we want to enter our IP in the browser, basically we want to go directly to that IP, with nothing before or after it. So here we want to tell our server that when there's just a plain slash, meaning when we've only entered our IP. What should it do? It should come and display our web page. As for how this web page is displayed, I'll explain that in the next part. For now, I want you to understand the structure of the program. It comes and displays our web page. When we enter just the plain IP, now if the rl1 command has been sent after our IP, if you remember when we pressed a button, an rl command with a number from 1 to 5 would be sent. We say, if the rl1 command is sent, what should it do? It should handle the corresponding relay. Look, for rl, 1 is separate, 2 is separate, 3 to 5. For 1 to 5, it comes for relays 1 to 5. What does it do? It performs a digital write, meaning it sets the pin for relay 1 digitally. What about the toggle? It's the opposite, a digital read of relay 1, then this exclamation mark comes, and it inverts it. What does that mean? It means, for example, right now, our relay 1 is at 0. It does a digital read, okay, the digital read of relay 1 is 0, with an exclamation mark after it, it becomes 1, so then it does a digital write to relay 1, with what value? 1. So basically, this command inverts the pin, right? Meaning if it's 0, it turns it to 1, and if it's 1, it turns it to 0. And that's exactly what we saw in the normal mode. It comes and updates the user's web page and sends the web page to them again. Similarly, for relays 2, 3, 4, and 5, and finally, we come and start the server and run it inside the void. In the loop, we use the server handle client command. We tell the server that if a client has made a request, respond to the request and add a delay. We also add a millisecond delay here so that our microcontroller doesn't hang. That means every 10 milliseconds it checks, and if a new command has been sent, it responds to it. Now, the last topic that remains is how our web page gets updated. Look, we have a command in the C language. It's called sprintf. What does sprintf do? Its job is to take a set of variables and store them in a specific format for us. It stores a set of variables in a specific character format. For example, if I want to give an example here, let's say we write, it comes, sprint. For example, in that character buffer we created above, the HTML buffer, we say put it in the HTML buffer. With this format, for example, let's say number is %d. Now what does this do? Sprintf has a set of commands or formatting options that you can use. For instance, here %d is for integers, which means whole numbers. %f is for floating point numbers, which are numbers with decimal points. You can use these options to control how your output looks. You can find tutorials for sprintf on the internet, or for example, %s is for inserting a character. What does this do? It says number is 2, and then the number, which is this value, is placed inside the HTML buffer. We assign it, meaning it formats our variable, and for example here you can, instead of 50, we put a numeric variable, and then the value that the variable holds. I substitute it here. Now we use this very technique. If we go back to our HTML code, there was a very important part in our code where we specified the state of the relays in our main code. Here we had set it to 0, but now we replace that 0 with those percentage values. Exactly what I just summarized for you here as an example, like here where we had a percentage value, I put 50 in it. What if we have several percentage values here? For example, now here we have 2, and let's separate them from each other. It puts 50 in the first one and 20 in the second one. So here we add 5 more percentage signs to the HTML code. Now what happens? When we use sprintf and want to use these codes, like right here, we say, where is it supposed to store the code? Inside the HTML buffer. But in what format? Here we manually wrote our format and specified it for it. Now we say, instead of writing the format manually here, let it take our format from the HTML page. What does that mean? It means that instead of this, it will put this entire section. All of our HTML code, and then what does it do? It takes these 5 variables, which are our 5 relays, and puts their statuses in order inside this. It puts them in the Ds. If the relay is 0, it puts 0. If it's 1, it puts 1 in these, and that's pretty clear. Using the digital read command, we use it to read whether a pin is 0 or 1, and here we did just that. We said, in order, do a digital read for relay 1, relay 2, up to relay 5. In this, in the Ds, and when it fetched these structures from inside the HTML page, it replaced them and put them inside the HTML buffer. Now we send the HTML buffer to our server. How is it sent? It's done in such a way that we have an HTTP code, which is a specialized topic if I want to explain it. But it's like, for example, maybe you've experienced searching for something on a website. You do it, and it gives you an HTTP 404 code, meaning something wasn't found. But on the other hand, there's the HTTP 200 code. That means everything was okay and everything was done correctly. So here we tell it to send it to our server, send the 200 code properly to our client, and then what should you send? Send an HTML page. What kind of HTML? HTML. With the file that we placed here, it comes like this and sends this part to the user. The whole format that was created, what was our main command? It was server on. In short, this command says server on slash, server on slash, come. Send such and such thing, server on URL 1, come and send such and such thing, and this whole structure works like this. And another point is that if like now your code is short, you can easily write it right here. But let's say, for example, if, for instance, you wanted to put a lot of code in this section, we can write exactly the same thing like this, right here. And instead of Using this block of code, for example, here we say to go to the function, let's suppose. For example, HTML. Handle HTML elements such as the root element. For instance, it goes here, and then we add a function called handle root at the end. For example, HTML video, which is commonly used in web pages, handler root. Like this, we add a function at the end, and it's exactly these 3 lines. We put the command we had here in this place as well, and in this way the code, it works perfectly fine and there's no problem with it at all. But since our code was short, we could use this structure you saw here. Let me delete these items so it doesn't get mixed up. This structure basically acts as a function, and it treats it as if it's a separate function and to execute the commands carefully placed inside it. So this becomes the overall structure of our program. Now, when I save this file and click the upload button, as you can see, now the code is compiling. Once the compilation is done, it moves on to uploading and starts uploading. And now our microcontroller is ready. Now if I open the Wi-Fi menu, now you'll see a Wi-Fi network named CWS. And if I try to connect to this Wi-Fi, it asks me for a password. Now I enter 1, 2, 3, 4, 5, 6, 7, 8, which we had in our code, and as you can see, I tap next so it connects. At this stage, it's connected, but since there's no internet, it's still checking to see if it has internet access or not. Our ESP isn't a modem, so it doesn't have internet access. Once it reaches this stage, now all we need to do is open our browser and enter the IP address we specified. 192.168.1.10, and you'll see that our page loads. It's that simple. And now, whenever we click any of these buttons, you'll see that the corresponding relay toggles. Now relay 1 is on. If I click it again, it turns off. Click again, it turns on. And if I want to show you here as well, let me show you. This is my hardware, and now I'm pressing relay 1. Relay 2, relay 3, 4, and 5. Now, I'm turning off relay 2, then turning off relay 5, 3, 4, and 1. As you can see, our code is working absolutely perfectly, at a very good speed, and without any issues at all. I sincerely hope you've enjoyed this tutorial series. I really tried to keep the sessions short, but I hope the content has been useful for you, and that you can use it and enjoy it. Thank you very much. Thank you for staying with me, and until the next courses, goodbye for now.